Welcome to this short video on the sinusoidal source, which is part of videos for circuit analysis in the frequency domain. A sinusoidal signal source produces a signal that varies sinusoidally with time. The signal can be voltage or current. A sinusoidal voltage or current source can be mathematically expressed by either a sine or cosine function. We have decided to use the cosine function and will continue with this choice throughout the discussion. The parameter Vm or Im is the amplitude of the sinusoidal function and denotes the maximum value of the sinusoidal function. The sinusoidal function is periodic, meaning that it repeats at regular intervals. The time required for a sinusoidal function to go through all its values is referred to as its period and is represented by uppercase T. It is measured in seconds. After one period has elapsed, the signal just repeats itself with the same pattern. Related to the period of a sinusoidal function is its frequency, which indicates the number of cycles per second. Given the period of a sinusoidal function, its frequency can be obtained by the reciprocal of the period. Frequency is measured in hertz. The frequency must be converted to a form that when multiplied by time, it results in an angle, so that the sinusoidal function can provide its sine or cosine. This is why we have angular frequency, represented by lowercase omega. The angular frequency is obtained by multiplying the frequency by 2 times pi. The unit of angular frequency is radians per second. Here, you can see the plot of a sinusoidal voltage source with frequency of 1 kHz and amplitude of 1 volt. The period is 1 millisecond. Therefore, in 10 milliseconds, 10 cycles of the signal are present. Because the amplitude is 1, the voltage varies sinusoidally between -1 and 1. Another parameter of a sinusoidal function is its phase angle, which determines the value of the sinusoidal function at time 0. The plot of the sinusoidal function that you saw in the previous slide had phase angle of 0. Here, you can see it with the phase angle of 30 degrees. The other parameters are left unchanged. Here you can see the same sinusoidal function but with a phase angle of 90 degrees. We may often see the phase angle expressed in degrees, but note that when doing the calculations, both omega t and the phase angle must be in the same units. We can easily convert between the two units by knowing that pi radians is equivalent to 180 degrees. 2 examples are given here for converting from degrees to radians and vice versa. A sinusoidal voltage or current may be expressed as RMS value. The RMS value of a periodic function is defined as the square root of the mean value of the squared function. If we use the power reduction formula applicable to cosine squared, we realize that the RMS value of the sinusoidal function is its amplitude over square root of 2.